I thought I'd do a quick mini project, or it could be a full project for EE97, showing how to use the PSOC. So the PSOC has an op amp, but it doesn't have dual supplies. The N side is tied to ground, and the P side is tied to nominally 5 volts or 3.3. So everything has to be a single rail. And this can be done with an advanced summing technique, which isn't covered in EE98, but it is in 110. I have a whole manual on how to do this. But essentially, if this number here, right, 10K, is the same there, and then if you take the ratios of this to these, 10K divided by, and sum it, and take the same ratio here and sum it, and if it equals the same thing, it all works out. Kind of hard to derive, but easy to use. Just to make sure I wasn't going crazy, I had the gains that I wanted, right? 1 bit would be half a VDD, a quarter VDD, and then 0.125. I started off with 10K and then calculated what the input resistance should be, right? I tried 100K first, but then it got too big. Now, in order to get the gains match, right, I sum these gains, I get 0.875 and calculate what the resistance should be. There is no resistor at quite that value. So what you do, let's do it the easy way and let physics take care of it for you. So if I have 20, 40, 80, right, and if I wanted that same in this architecture, the 10 is here, I have a 10K here, right? It all works out if I just put 20, 40, 80 tied to 0, okay? So that's a superposition, but the input is 0. But anyway, putting all these in parallel will actually balance the gain, so the circuit works. So then when you run it, you can see it stepping quite nicely. It doesn't go up to 5 volts because there's only 0 is one logic level. So 1, 2, 3, 4, 5, 6, 7, 8, right? There's only 8 logic levels. So 7 times 0.125 times 5 is 4.375. So this is working. All right, now that you've seen that design, how do we do it in the PSOC? All right, so I'm just going to zoom in a bit here. So it has an op amp, and you just, drag it in, okay? You got to make sure you configure it properly. And you just have, because we're going to put it to an output pin, it normally comes internal only. You'll get an error message if you don't click sending it to output like I was earlier. And then you have 3 pins, and it's all analog signals, and you just drag the 3 pins here. All right. So these are all real PSOC things, the 3 pins and the op amp. All right. All these things in blue are just notes to the designer about what you want to do. And they come from off chip where you have ground and resistors and all of that. And you can see I have 80, 40, 20, 80, 40, 20. The op amp is, upside down. So the input terminal, negative input terminal is here. So that's why they're at ground. And then here are my voltage supplies. Okay. Right. Now this won't simulate. You actually have to build the circuit. But, if I press build, I have a PSOC put in, right? It programmed it in just about the amount of time that, a simulation would take, except you have to build this circuit, right? So what would that look like? Well, this is the kit. and they can be hard to see, but here are all the pins. The pins get assigned automatically when you build, but you can click on pins and it will show you, right? This is the actual chip and the pins that are assigned. But this, because it's set up for the kit, it knows that pin 51 goes to P50. Right? If you just bought this chip and were doing your own board, you'd have to reconfigure that. So anyway, that pin 2, or no, where's pin 1? Pin 1 is the positive terminal, right? And that's P50. That's there. That's the other input terminal, and that's the output terminal. And you would have to build these circuits on your breadboard to connect it. We do have breadboards for your use, and I need to get more kits in lab for you. So you would then build it, and then you could run it. Now then that comes back to testing. I'm going to go back to the PSOC view. All right. Where I have 3 inputs, right? I think the function generator might have 1, maybe 2. Scopy, or the M2K, I think you have one in lab. It has 2 analog channels, and it has 16 digital channels, so you could test it with that. But this would be in another video, but you can actually use the PSOC's CPU to actually test the circuit, in that I can add some pins, right, that are for, I'll just make them digital output pin, okay, and make sure I configure it right correctly. Digital output enable, strong drive. You tend to have to give it a drive value that can be overridden, but it's a place to start. So this means if you do nothing, the pin will go high. Okay. And now I'm going to delete that and rotate that. No, actually I'm just going to leave it there. So this pin can be controlled by the actual CPU, and you would wire it up, essentially. So I'm going to build it. I think it wants to be connected to something. Actually, this is a separate video, okay? But here, there's something that right, I could say pin, that's pin 4, pin 4, right, the opposite, or the inverted, of pin 4 read. think I should. I'll just set it to some starting value. This will just compile everything. All right, so I haven't quite set. Oh wait, because pin 4 read. All right, I still have to fix some things, but that's okay. The important part is I can toggle that input and it'll go from high to low. This pin hasn't been assigned yet. Again, I have to fix that, but that's not the part of this video, is that you can make a 3 input digital to analog converter with an op amp, do some resistors here, and that I haven't shown you exactly how, but you can actually write your test vectors here rather than use the function generator. And you can, on your oscilloscope, right, you would be able to monitor that pin to get what the voltage is. And you can actually get it, save it to the oscilloscope, save, and then bring it back and then look at pin 3. So you can get it all on one thing with a little bit of help. Anyway, I'm going to do the other video shortly to show you how to do the pins.